Hello everyone, welcome to this new video on PySpark, which is a Python API for Apache Spark. So Apache Spark is a multi-language engine for executing data engineering, data science, and machine learning on single-node machines or clusters. Uh, some history on Apache Spark. I studied as a research project at the UC Berkeley AMP Lab in 2009, and it was later open sourced in early 2010. After being released, Spark grew into a broad developer community and was later moved to the Apache Software Foundation in 2013. Some key features, it is fast owing to its in-memory computation and optimization techniques like lazy evaluation, pipelining, and query optimization. Another key feature of Apache Spark, it's easy to use. Spark provides simple and high-level APIs in multiple languages, including Scala, Java, Python, and R, making it more accessible to a wide range of users. Spark is also designed to scale horizontally across large clusters, efficiently distributing data processing tasks and allowing users to handle petabytes of data. And it also provides a unified programming model for both batch and stream processing, which enables developers to write code for both workloads using the same API and programming constructs. So overall, Apache Spark has become a more popular choice for big data processing and analytics, widely used in industries such as finance, healthcare, and more. PySpark is included in the official releases of Spark available in the Apache Spark website. Python users can use pip installation from PyPy. They would require Java's JDK and also need to download Spark files from the Spark website. PySpark DataFrames are lazily evaluated. What this means is that when Spark transforms any data, so it does not immediately compute the transformation, but it only plans how to compute this later. So when an action such as collect method is explicitly called, only then the computation starts. So the entry point into all functionality in Spark is a Spark session. Which we could import from PySpark.sql. So we can create PySpark.sql from PySpark.sql, import Spark session, and then we could create a Spark session using Spark session .builder .get or create. Spark SQL is a module for structured data processing. It supports operating on a variety of data sources through the DataFrame interface, including Parquet, CSV, JSON, Apache ORC, and Avro file formats. We can create data frame using create data frame method or use spark.read to read data from different data sources. We can also run multiple operations on data frame, and these are very similar to the pandas data frame. For example, we can select one or more columns with df.select, filter data using different conditions with df.filter, add column with df with column, or drop one or more columns with df.drop. So df here is the data frame, and also run. We can also run other grouping and aggregate operations. We can also use SQL commands, as both data frame and Spark SQL share the same execution engine. So for example, we can register the data frame as a table. So df.create or replace temp view is registering the data frame, and we could name that table. For example, in this case, in the query, we are using a table with the name of table A. And then we can run an SQL query. So we can run a SQL query, which in this case returns a count of rows in table A. So this was a brief overview of PySpark DataFrame API. So let's move to the Jupyter notebook and see how some of these operations work. Okay, so this is our Jupyter notebook, and in this exercise, so we will do the following tasks. So we'll create a Spark session. We'll load a CSV data. We'll check schema and show data frame entries, then check data types and column names. We'll also see how to drop one or more columns from the data frame, how to rename those columns, how to generate some statistics using the describe functionality, and how to check missing values in the data frame. Then we will see how to use SQL or SQL queries to retrieve information from the data frame. Then we will see how to add one or more columns to our data frame. And finally, we will look at the aggregate functionality. In this exercise, we will use the housing dataset, which I downloaded from Kaggle's website. So this is the dataset. You can see it has 7 columns and shows information from income, house age, number of rooms, number of bedrooms, population, price, and address. So let's see how we can create Spark session. So to do that, we will use PySpark.sql. From there, we will import Spark session, and we will also import two other utility functions. Which we will be using later in this exercise. So those we will use import from PySpark SQL functions, and the utility functions are call, which is short for column. It is used to reference a column in a data frame, and it allows us to perform various operations or transformations on a specific column. And average is used to calculate the average from a column. Okay, so Spark, we can create this session using Spark session .builder.app name, and here I have named it as DataFrames, and then we'll do .get.create. And if we run the first cell and the second cell, uh, we see we have our Spark session here. So Spark UI here is a web-based data dashboard. So if we look at this dashboard here, so this dashboard is provided by Apache Spark to help us monitor and manage Spark applications. So environment, so we could see spark.app.name, and that's our app name data frames. So local here, it means that we are running Spark locally with as many work threads as logical cores on our machine, local machine. And our app name, again, is DataFrames. So now let's see how we could load our CSV data. So let's use the spark.read.csv, and this is the file name, housing.csv, and we will use print schema to display the um, schema or the structure of our data frame. Um, so let's run this, and we could see that it has read 7 columns from the CSV, so C0 to C6, and these are the data types. So and nullable equal to true means that these columns can have null values. Okay, so few problems here. So if you look at our CSV file, so we have this header uh, showing the column names, which this command didn't read, so we don't see these column names over here. Instead, we see the C0 to C6 as column names. So in order to see the column names, we should give another option in the read.csv argument. So header equal to true, and if we run this again, so now all those column names appear in the load function, but that solves only one problem. The other problem is that all of these data types for these columns appear to be a string, which is not the case because we could see that in income is a number, house age is a number, rooms, population, price, only the address is a string. So in order to infer schema from the CSV file, so we could set the infer schema option equal to true, and then if we run it again, so now we see that some of these columns types have been changed to double, but still for the first two columns, income and house age, we see the data type as a string. So what could be the problem here? So here the problem is, if we look at the CSV file in our notebook, we see that these entries, these row entries, have been extended to multi-line. So 2 lines. In this case, in order to read the file accurately, we will use another option, which is multi-line set to true. And if we run this cell again, so now all the data types for each of these columns have been converted to their correct data types, which is double. So let's save this data into a data frame. So df equal to spark.read.csv. So df is the data frame here. So now let's see how we can check schema and show data frame. So we have already seen how to check schema, so which is using the command print schema. So here we could rerun it again, df.print schema, and we see the information here. So column names and the data types and the options. So we could display the entries of the data frame using the df.show command. So by default, it shows the top 20 rows, but we could reset it to as many rows as we want to display. So in this case, it is set to 3. So we'll only see 3 top rows of the data frame, and these are the numbers. We could also see the column names, so which are shown here, but we could use df.columns, and it will display the column names as a list. df.dtypes is used to display the data types. Previously, we saw used print schema in which we could also see the data type of each column, but we could use this as well, df.dtypes, to figure out the data type for each column. Okay, so now in this data frame, we have 6 columns which are of type double, whereas only one column has the data type of string. So we let's say we want to remove this column from our data frame, so we can use df.drop and we can enter the column name. So if there are more than one column, so we can enter their names as a list, and it will work as well. So df.drop address.show, and we could see that the column name is being dropped from the data frame. So this is not an in-place operation. So in order to save this change into our data frame, we'll have to use df equal to df.drop and the column name. So, and then if we look at our data frame again, so our new data frame does not have the address column. Um, Another thing is that the column name, so we could rename these columns and make them look more concise. So we will use the underscore separator and use all lowercase text. Um, so for that, let's first save the column names as df.columns, and then we'll use this code here. So this lambda function here, which will take the column name and then do this conversion. Okay, so let's break this lambda function and see how we could rename the columns um, to a more concise form, all lowercase separated by underscore. So let's take the second entry, so column names one, which is average area house age, and then we split it on the word area, and we see that we have two values, average and house age. So we'll take the last value, so which is house age. So then we see some white space here as well. We could use the strip method to strip the white space, and then we can use the lower method to make everything lowercase, and we could also strip split um, this text again on the empty space. So we see that house age. Now we could use the underscore dot join to output the name as house underscore age. Um, So this is how this lambda function will work. After that, what we want to do, we want to create a column map. So it's a dictionary. So where we have the original name as the keys of that dictionary, and then we will use the renamed column name as their corresponding value. So let's look at uh, this dictionary. So we see average area income has been changed to income. Average area house age has been changed to house underscore age. Average area number of rooms has been changed to number of rooms, and so on. So in this, we'll read the key values from the column map.items, and then for each key value, we'll use the df.with column renamed and give it as a key value. So this will rename the column with its original name that was set as a key, and then the new value as the current value corresponding to the key. So if run this cell again, so we'll see that if we do df.columns, so all the columns have been changed to their new names, all lowercase, underscore, and the average area part from the original names have been removed. So often we are also interested in seeing some basic statistics for different columns. We could use the df.describe functionality and provide the columns as the input argument. And if we run this cell here, so we could see we get the basic statistics on each of these columns. So the number of values, so count, mean, standard deviation, and min and max of the entries in each column. So all of these columns have the count set to 5,000, so which shows that we don't have any missing values here as well. But we could also see the missing values using df.filter, and we'll use this call a utility function, provide the name of the column, so which in this case is number of rooms, and then we could check whether it contains null values or not. So we could say is null, and then we can count those entries, and if we run this, in this case, we get 0 because there are no null values, but we can also see how many values are not null. So it's not null, we get the same 5,000 values as we see in this count here. For all columns, we could uh, use this code over here. So we'll start with the missing value set to 0, and then we'll repeat what we have done in the previous cell for each of the columns, and then add the missing values to the total. So um, we run this, so we see that the total number of missing values is 0 in this data frame. But if we have missing values in our data, we could use the drop NA or fill NA method or methods to treat the missing values as required. Okay, so next we will see how to retrieve information using SQL queries or SQL queries. So for that, we'll first have to register the data frame as a table. So this is the command to do that. So df create or replace temp view. So and we'll name the table as housing. And then we could use spark.sql and then write a SQL query. So in this case, select count from housing, so which should return the total number of rows in the data frame. And if we run this command, so we see that it's 5,000. Next, we will see how to add column to our data frame. We could do that using df.withColumn, and this is the column name that we want our new column to be called. So we'll use the call utility function, and the new column here is the room to bedroom ratio. So we'll compute the ratio as the number of rooms divided by the number of bedrooms. And if we use dot show and show only the first two rows of the data frame, so now we have room to bedroom ratio column in our data frame. So again, like this is not an in-place operation, so we'll have to save it. If we want to save this column into our data frame, so we'll have to say, use df equal before this command. Okay, so next we'll do some more exercises. And to explain filtering and aggregate operations. So let's look at the exercise first. So first exercise, let's first find number of houses with prices more than 1.5 million. And so this is n is equal to 1.5 million in this case, and then we'll use this formatted string and print this um, text here with the information. So this data set has, and we will use the df.filter. So in that we'll set df price greater than n, because we want to see the houses that are that have price greater than 1.5 million. And then once we'll have our filtered data frame, we will count the total number of rows, and that should give us the total number of houses with the price greater than 1.5 million. So let's run this cell. So it shows that this data set has 1,135 houses above $1.5 million price range. Okay, so let's look at another exercise. So where we want to uh, know the average total rooms to bedroom ratio for for houses that are greater than $2 million price. Okay, so in this case, our price threshold is $2 million. So we will use the same filter operation to first filter out the data frame with houses that have prices greater than $2 million, and then we'll use the with column uh, functionality to add the room to bedroom ratio, and then calculate the room to bedroom ratio as we did before. So, and here we will set the new data frame as df underscore expensive. So these are expensive houses. Um, and if we want to show our data frame, so let's show 5 entries this time. So df underscore expensive dot show, and we can see the room to bedroom ratio. But what we were interested in was to get the average total room. So what is the average total room to bedroom ratio for these houses? So in order to do that, we could use the aggregate functionality here. So df dot underscore expensive dot aggregate, and then we will use the average uh, function on R2 BR ratio column, and then we could display the results. So which is 1.97. So all these expensive houses on average have half of their rooms as bedrooms. Okay, so we have gone through all of the tasks in our current exercise. So when we are done with the Spark session, so the best practice is to use spark.stop, and that's it. So it will close the Spark session. Okay, so this was a brief overview of PySpark Dataframe API. So in the next part of this video, we will use the ML from Spark to create a machine learning pipeline. See you all in the next video, and thank you for watching, and please subscribe to the channel, like the video, and leave any feedback in the comment section. Thank you.